Now, what is going to happen? The velocity will be 0 at this point, gradually increase till it reaches this. So this follows a curve. This follows a curve like this. What this curve is showing you, it is showing that for some point velocity was negligible to 0, was approximately 0. It keeps on increasing to a point where it reaches the average, and then it is constant. All right. So as we know, at this point velocity is 0, so Reynolds number will be 0. Okay. At this point velocity is maximum or average, so Reynolds number is going to be rho u L by mu. Okay. Somewhat say here. Let us assume Reynolds number is 500. So till there. Okay. Till this point, let us assume the flow has attained some velocity. It has attained some velocity. And at this point, Reynolds number is 500. Reynolds number 500 means the flow is lambda. So in this layer, flow is laminar. Therefore, it is also known as viscous या फिर laminar sublayer. Laminar sublayer. From here till here, this is a transitional phase. Transitional, where Reynolds number and velocity both are going to increase gradually. They are going to increase gradually. So this is my transitional layer. Reynolds number will keep on increasing, and this entire layer, from here to here, I am talking about this layer. This entire layer is known as my boundary layer. What is laminar sublayer? Laminar sublayer is a layer within the viscous boundary layer. What is boundary layer? Boundary layer is a layer in which flow gradually increases from 0 till the flow is turbulent. So here I can say that the flow is turbulent. The flow is turbulent. Am I clear? Sometimes what happens? So a lot of particles are moving in this laminar sublayer, But sometimes, first you copy this down. So particles now, see, if you see the movement of particles, so the particles are essentially going to move parallel to each other. Why? Because it is a laminar layer. In transitional zone, the particles are going to move somewhat like this, with slight interaction, somewhat like this, isn't it? With slight interaction. And in turbulent layer, the particles are going to move in a very haphazard manner, in a very turbulent manner. Okay. But what happens? What I'm trying to tell you, the bed roughness also plays a key role, which is not encountered, which is not actually included in the definition of a boundary layer. Say for example, I've got a grain over here. In natural conditions, I usually witness some grains. So what happens is the flow comes like this. It was parallel, but due to this encounter with grain, it moves in the transitional zone, and the flow changes rapidly to from laminar to transitional, like this. So this is not included in the definition of viscous layer, but it actually plays a role in reality. All right.